In this video, we use dynamic statistical graphics to visualize structure in high-dimensional multivariate data. The data we will visually explore concern the rate of each of the 7 major types of crime in each of the 50 United States. These data are 7-dimensional. This is the initial display constructed by visuals. It shows the relationship between states and crimes. The white cubes represent states, the red vectors crimes. The display shows the 3-dimensional space formed by the first 3 principal components of the data. This is the 3-dimensional view of the data that shows the most variation. The first component is horizontal, the second vertical, while the third points towards us. The 50 cubes are located according to the scores of the 50 states on the 3 principal components. The 7 red vectors are located according to the coefficients of the 7 crimes on the 3 components. The cubes and vectors have been orthogonally projected from the 7-dimensional data space into this 3-dimensional visual space. Crime vectors point in the direction of high crime rate. States on the right, New York, Nevada, Florida, and California, have high rates. States on the left, North and South Dakota, have low rates. Since vectors for property crimes, auto theft, larceny, burglary, and robbery, point upwards, and vectors for personal crimes, rape, assault, and murder, point downwards, the vertical dimension separates property crimes from personal crimes. Previous visual exploration of these data revealed a cluster of southern states that have similar crime patterns. Here these states are red. Florida, which is not in this cluster, is yellow. The crime variables are invisible. Note that the southern states are at the bottom of the space. This is the region of the space with high personal crime rates. Southern states have disproportionately high rates of personal crime. Now we spin the 3D space to see if the 2-dimensional cluster of southern states is a cluster in 3 dimensions. Looking at the spinning space confirms that it is. Florida is still by itself. We proceed to use visuals to investigate whether the 3-dimensional cluster of southern states is a cluster in 6 dimensions. To do this, we have already defined a second 3D space so we can rotate in 6 dimensions from the currently visible 3D space to this other 3D space. The second space has dimensions which are principal components 4, 5, and 6. This is the largest space which is orthogonal to the visible space. That is, it is the largest space that is currently invisible. Now we are ready to switch to the second 3D space. Now we spin the second space to see if the southern states still form one cluster. Spinning seems to show they do. However, while the southern states seem to form a single cluster in both 3D spaces, rotating in 6 dimensions between the 2 3D spaces will reveal that North and South Carolina are separated from the others. For this scene, we have made all the states invisible except the southern states. Thus, we see only southern states. We are now looking at the first space and are about to switch to the second space. Now we are looking at the second space. For emphasis, North and South Carolina are red. Florida is still yellow, and the remaining southern states are still white. In the next scene, we will tour high-dimensional space. For simplicity, we begin by touring 4-dimensional space. In later scenes, we will tour 6-dimensional space. What we look at is paths of movement. States which follow similar paths are close together in high-dimensional space. States that follow different paths are far apart. We see that the red states, the Carolinas, follow similar paths, paths which are different from those taken by the white states. Careful inspection suggests that the white states may themselves divide into 2 clusters, one of Mississippi, Alabama, and Louisiana, the other of Georgia, Arkansas, and Tennessee. We will investigate this further in the next scene. Note that this 4-dimensional tour involves rotating back and forth between the XY planes and the 2 target spaces, planes formed by components 1 and 2, and by 4 and 5. The four-dimensional guided tour continues with the states colored to emphasize clustering. Now, Georgia, Arkansas, and Tennessee are blue, while Mississippi, Alabama, and Louisiana are white. We see that the red cubes, the Carolinas, move along similar paths. The white ones, Mississippi, Alabama, and Louisiana, move along another set of similar paths. The blue ones, Georgia, Arkansas, and Tennessee, move along a third set of similar paths. Note that the color changes were not made before identifying the clusters. Rather, the changes were made after visual exploration revealed the clusters. After all, the changes require knowledge of the clusters that we didn't have prior to visual exploration. Now we tour six-dimensional space by combining 3D spinning with six-dimensional rotation. This tour of six-dimensional space helps us conclude that there seem to be 4 different patterns of crime in these 9 southern states. We now use projection fit cueing to further investigate the structure of the southern states. The brightness of objects varies as the three-dimensional visual space rotates through the high-dimensional data space. When an object is bright, a large proportion of a state's total variance appears in visual space. When an object is dim, little of the state's variance is shown in visual space. If several states are clustered in about the same place in the high-dimensional space, then, as visual space rotates through data space, the several states should display similar patterns of changing brightness. In this example, we see that cubes that are the same color change brightness in similar fashion, further supporting the conclusion that the states are clustered in high-dimensional data space. Note that we do not see these clusters as spatial clusters in any portion of the video. Rather, we see them as movement and brightness clusters. Indeed, it may be the case that we cannot see a high-dimensional spatial structure in any low-dimensional static projection. For our example, there may be no 2 or 3D projection that shows these 3 groups of states as spatially separated clusters. However, the movement and brightness clusters imply that spatial clusters do exist in 6 dimensions. Thus, visuals gives us a way of visualizing the structure of high-dimensional data space by encoding the structure as movement and changing brightness in visual space. Finally, we return to the full plot of all 50 states to see if the 6-dimensional rotation tool, augmented with projection fit cueing, will reveal additional structure of interest. As you watch this space, please note the Alaska cube. It moves from the center, where it is now, to the upper right-hand corner as we rotate from the space defined by the first 3 principal components to the space defined by the last 3 components. Alaska, the AK cube, is moving towards the upper right corner now. When Alaska is in the corner, we are seeing the space defined by the last 3 principal components. Also, when it is in the corner, Alaska's cube is bright, and as it moves to the center, it becomes dim. Notice that its brightness changes are opposite to the changes for most states. Alaska is dimmest when it is in the space defined by the first 3 principal components, the 3D space that accounts for the most variance. And it is brightest when it is in the space defined by the last 3 principal components, a 3D space which accounts for much less variance. We see that Alaska is an outlier. It is on the edge, and much of its variance is accounted for by components that account for little other variance. When we look at the original data, we see that Alaska is unusual. It has the highest rate of rape of any state in the country. We have shown you dynamic statistical graphics that use movement and brightness change to communicate information about the structure of high-dimensional space. These tools help us discover and visualize structure in multivariate data. We have discovered that Alaska has an unusual crime pattern and that there are 4 6-dimensional clusters among the crime patterns of the southern states. Exploring multivariate data with dynamic statistical graphics has helped us discover and visualize its high-dimensional structure.